Chapter 2, Sections 4 and 5. (2.4, 2.5) objectives. We've combined them. Learn to multiply and divide rational numbers. And our same essential question, how do I calculate with rational numbers? Remember, repeated addition and multiplication are one and the same. We could add 1/4, 1/4, 1/4 and get 3/4, or we could multiply 1/4 times 3 and get 3/4. So it's really the same concept, adding all the numerators as it is to multiply the numerator by the number of times you repeat it. Just a quick refresher, rules for multiplying two rational numbers are the same as they were for integers. Two positives or two negatives make a positive. If the signs are different, one of each, a positive and a negative, is a negative. Mark runs 1/7 of a mile each day. What is the total distance Mark runs in a 5-day week? So we could add 1/7 plus 1/7 plus 1/7 5 times, or we could multiply 1/7 times 5. Multiplication, we go straight across. We write 5 over 1 so that we remember that 5 is the numerator and 1 would be the denominator, and we get 5/7. Multiply again. Now we have -8 times 6/7. It's the numerator that's being multiplied by -8. -8 times 6 is -48, so we end up with -48 over 7. Remember, I'm okay with improper fractions as long as they are reduced. Fractions in lowest terms are simplest form when the numerator and denominator have no common factors. Multiply again. 1/8 times 6/7. Pretty straightforward, you multiply straight across. We could do that and get 6 over 56. What we can also look for is if they have common factors. So in the numerator, we have a 6, and in the denominator, we have an 8. Both of those numbers can be divided by 2. So we can cancel some things out before we multiply. 6 divided by 2 is 3, 8 divided by 2 is 4. Now it's 1 times 3 and 4 times 7. This makes our problem a little bit easier as our numbers get smaller to work with. Let's try another one. -2/3 and 9/2. Look for common patterns in the numerators and denominators. Well, the 2's can be reduced, and the 3's, 9 and 3 can be reduced. So the 2's divide out to be -1 and 1. 9 divides by 3 to be 3. 3 divides by 3 to be 1. So we get -3. Let's try the example in your notes. We have 5/36 times 9/25. So I know that 5 can be divided by 5 to give me 1, and 25 can be divided by 5 to give me 5. I also know that 9 can be divided by 9 to give me 1, and 36 can be divided by 9 to give me 4. So now what I really have is 1 over 4 times 1 over 5. Multiply the numerators to get 1, denominators to get 20. That was a lot easier than having to take the time to multiply 36 times 25 and figure out how to reduce after. Next step, dividing fractions. We need to know what reciprocal means. A number and its reciprocal have a product of 1. To find the reciprocal of a fraction, exchange the numerator and the denominator. That means trade their places. Remember that an integer can be written as a fraction with a denominator of 1. So what does this look like? If our number is 3/4, our reciprocal is 4/3. We just switch them around. If our number is a -5/12, our reciprocal is -12/5. And if our number is 6, the reciprocal will be 1 over 6. Keep in mind that when you have a whole number or an integer, you can put a 1 underneath it, and that's where the 1/6 comes from. Notice that when it was a negative, it stayed negative, and when it was a positive, it stayed positive. Multiplication and division are inverse operations. They undo each other. So if we multiply something 1/3 times 2/5 to equal 2/15, if we take our answer to that and divide it by 2/5, we'll get back to 1/3. If we were to take 2/15 times 5/2, we also get 1/3. Normally we can't always divide because 15 divided by 5 nicely, 2 divided by 2 nicely. Doesn't always work that way. So we have some steps to follow. When we are dividing, leave the first fraction as it is. Change the second fraction to its reciprocal. Then we multiply straight across and simplify. So in reality, we are completely avoiding any division. So let's try it. 5/11 divided by 1/2. Following our steps, we leave the first fraction as 5/11. We take the reciprocal of 1/2, which is 2/1, and we set it up as a multiplication problem. We look for any simplifying. In this case, there is none. We multiply 5 times 2 and 11 times 1 and get 10/11. If we're working with a mixed number, first thing we need to do is change that to an improper fraction. So that would be 2 times 8 plus 3. So we get 19/8, and notice we also put the 2 as 2/1. So following our steps, we keep it as 19/8, take the reciprocal of 2/1, which would be 1/2, and set it up as multiplication. Again, nothing that can be canceled. So we get 19 times 1 over 8 times 2, which is 19/16, and I'm okay with it being left that way. If you really wanted to change to a mixed number, it would be 1 3/16. Last example, evaluate the expression for the given value of the variable. So we start by substituting in for k. K divided by 4/5 for k equals 5. So we plug 5 in. 5 divided by 4/5 is the same as 5/1. We've already jumped ahead a step and taken the reciprocal of 4/5 to be 5/4, set it up as multiplication. Nothing can be simplified, so we get 25/4, which equals, if you were to separate that out into a mixed number, 6 1/4. Make sure your notes are filled in completely and that you've highlighted important information. Review your notes and complete the summary before class, and come prepared to take a formative lesson quiz on how well you understood the material.